mute your audio and video. One minute, just I'm taking the pen here. There is a problem here, sensitivity has lost. Okay, now it's fine. Okay, we'll start. Yesterday we have seen the vector algebra, addition, subtraction, multiplication and division, and also we have seen the rectangular coordinate system, right? So a rectangular coordinate system consists of three planes: x equal to 0 plane, y equal to 0 plane, and z equal to 0 plane. Also we can call it as xy plane, yz plane and zx plane. Three planes are there. Okay, we'll study more about a rectangular coordinate system. This forms the basis for this subject, electromagnetic theory. So we should be very thorough in all the three types of coordinate systems: locating the point, locating the planes. So yesterday we have seen the location of points. So yesterday I told location of planes, but I will take location of planes once again. So here let me try to locate x equal to 2. So location of planes, x equal to 2. X, y, z. Okay, x equal to 2. So x equal to 0 plane is this. Just I will draw this line. This is x equal to 0 plane. X equal to 0 plane. This plane has to be shifted because I want to locate x equal to 2 plane now. So this has to be shifted 2 units front in the x direction. 1 unit, 2 units. So make this as center, this point as center, and draw the plane parallel to z axis and y axis, parallel to y axis and z axis. So now this is x equal to 2 plane. Next I will take another one. Instead of taking z equal to minus 5, I will take z equal to minus 5. Let me try to locate this plane. X, y, z. Okay, z is negative here, so I'll take the negative z axis here. Okay, z equal to minus 5 means xy plane, right? Z equal to minus 5 means xy plane. So this is the xy plane. So this is z equal to 0 plane, also called as xy plane. So z equal to 0 plane or xy plane. So this has to be shifted minus 5 means along the negative z axis. So 1, 2, 3, minus 4, minus 5. So make this as center and draw the plane parallel to y axis and parallel to x axis. Yes, now this is z equal to minus 5. Yesterday I shown, so take another plane. Okay, fine. I hope you came to know how to locate these planes, right? So can you go for y equal to minus 3 plane? Can you draw y equal to minus 3 plane? Please try it out. All of you try to locate y equal to minus 3 plane. Just I will give some time. Maybe for 30 seconds I will wait. Then I will show you y equal to minus 3 plane, how to locate y equal to minus 3. I am waiting. I hope you are doing there. Try to locate y equal to minus 3 plane. Okay, doing y equal to minus 3 plane. Anybody? I hope you can. Anybody? If anybody is over, you can unmute and speak. Mine is over. Y equal to minus 3 plane. Please try to locate y equal to minus 3 plane. If anybody has drawn, please unmute yourself and respond. I have done it. For your verification, I will be showing you here.
Hello, sir.
Hello. Hello.
Sir, I have made it, sir.
You have made it? Okay. Just okay. I hope others have also done it. Just verify. I will draw it. Y equal to minus 3. I will verify. Please verify. So I will draw here. X, Y, and Z. So y equal to minus 3 means negative y axis is required. So draw the negative y axis. So y equal to 0 plane. Y equal to 0 means 0 plane means xz plane, right? Y equal to this one, parallel to x axis and parallel to z axis. This plane is nothing but y equal to 0 plane, also called as xz plane. Xz plane. So it has to be shifted by 3 units in the negative y direction. So minus 1. So I will be taking minus 2, minus 3. It will come here. So make this point as center, and the plane should be in such a way that it should be parallel to x axis and parallel to z axis. So first I will draw one line parallel to x axis here on the one side, and next I will take care that it is parallel to z axis next. Okay, it is parallel to z axis. Yes, this is parallel. Yes, I hope it is correct. Anybody has drawn correct? You can respond. Y equal to minus 3 plane.
Yes, sir.
Yes, it is correct. Yes, fine, good. Okay, location
Yes,
of
sir.
planes. I hope you understood location of points and location of planes in the rectangular coordinate system. I will move to the next topic.
Yes, sir.
Okay, fine, good. Next, I will move to the next topic. Base vectors, also called as unit vectors in rectangular coordinate system. Always, if I say rectangular coordinate system, I am referring to three-dimensional rectangular coordinate system. We are not studying 2D, three-dimensional only by default. X, Y, and Z. So there are two names for we can call them as unit vectors or base vectors. You know that by definition of unit vectors, the vectors which are used for indicating the direction but whose magnitude is unity. As the name itself is telling, unit vectors. If I take the magnitude of unit vectors, it will be unity, but these unit vectors or base vectors are helpful in indicating the direction, right? So we make use of unit vectors to indicate the direction, right? So I have x-axis, y-axis, and z-axis. Along x-axis, so I want to point along x direction, so I will make use of the base vector or unit vector. So I will make use of small letter a, and it is along x direction, so ax bar means ax vector. It is the unit vector directed along positive x-axis. Ax vector, unit vector directed along positive x-axis. Similarly, I will take the help of unit vector in order to indicate the direction along y-axis, ay vector. Similarly, along z-axis, so az vector. So ax vector, ay vector, az vector. These we call it as unit vectors. Unit vectors also called as are base vectors, but most of the times we call it as unit vectors only, not the base vector, right? And instead of, some people use ijk. You are familiar with ijk, but I prefer not to use ijk because we are studying cylindrical and spherical coordinate system. If you are used to ax, ay, az, then the other cylindrical coordinate system, how to represent unit vectors, it will be very easy for you people. So if you are adjusted to ijk, please stop it and use unit vector notation as ax, ay, and az. So these three are the unit vectors directed along x-axis, y-axis, and z-axis. Okay, some people use the notation ijk, already I told, and some people use here ux. ux cap also, cap or bar, whatever, ux, uy, cap, or some people use cap, some people use bar in some textbooks, but don't worry, but we will use this notation only. Don't get confused with other notations by referring to different books. So we will not use this ux, uy, uz. These are general notations of unit vectors. Okay. Next, position vector and distance vector. We have seen what is position vector and what is distance vector in the previous class, but here I want to illustrate how actually the position vector is represented and distance vector is represented in rectangular coordinate system, and what actually those vectors and their magnitudes, and how to realize this position vector in terms of distance vector. That we'll see here. First I will take the position vector, and first I will draw the rectangular coordinate system. So x, y, z, these are the three coordinates. So this is the origin. Then I will take one point here, P. So the coordinates may be x, y, z, or they may take some value also, P of something 1, 2, 3. It is not exactly to the dimension, just simply I have taken. Let it be P of x, y, z. I will not take P of 1, 2, 3. Then from origin I will join to point P. So this we call it as position vector, because the position vector one end is always origin. The coordinates of origin are 0, 0, 0. Then we should be very much familiar with the notation. So I can write OP vector, but this is not the standard notation. So I have to write OP vector as OP vector is equal to small r. Small r indicates position vector, RP vector. No need to write ROP like this. R, O, initial point and final point. We will not use for position vector, because if I write small r and P vector, it is understood that the origin will be there. One of the point is origin, right? So we will make use of this notation, RP vector. Please be careful, right? Okay. So how to write this position vector, RP vector? So RP vector is equal to so you can apply the distance formula also. One end is 0, 0, 0 origin, and another end is x, y, z. X minus 0. Distance formula you can apply. So x into ax, RP vector I am writing. Then subtract y minus 0. Y coordinate you have to subtract, y minus 0. So y into ay. Similarly, the third coordinate z minus 0. Subtract z coordinates. So z into az. So this is the position vector, right? So x, y, z, we call it as components of a vector or scalar components. X, y, z, we call it as scalar components or components of a vector, which will be coming in later on. There it will be helpful for you. So and ax, ay, az are called as unit vectors or base vectors. Is it fine? Okay. Next I will show you the distance vector now. Distance vector PQ in rectangular coordinate system. And I want to establish the relationship between the position vector and distance vector. X, y, z. Okay, this is the origin anyhow. So PQ vector means point P is, let me assume point P is here. The coordinates are x1, y1, z1. I will take one more point Q. The coordinates are x2, y2 and z2. Yes, I will join point P to Q. So this is the distance vector from P to Q I am taking, because PQ. So there should this is the distance vector, because for distance vector both the points are in the space, not at the origin. But for position vector, one of the point is at the origin. For distance vector, both the points are in the space, free space, right? So now I want to make use of notation. So instead of writing PQ, some people write PQ vector, but this is not the standard notation. So write down, instead of there for position vectors we have made use of small letter r. Here we will make use of capital letter R, and we will write P, the starting point of the vector, and Q, the terminating point of the vector, and put bar over it. So this is the standard notation. RPQ, capital RPQ will represent the distance vector, right? And I want to, okay, now I want to write a RPQ vector, RPQ vector. So I have point P, the coordinates of point P are x1, y1, z1, and I have point Q, the coordinates of point Q are x2, y2, z2. Then by using the distance formula, I can write the vector. First subtract the x coordinates, x2 minus x1, always terminating point minus the initial point. So x2 minus x1, x2 minus x1, it is along x direction, so x2 minus x1 into ax vector. Then coming to the next coordinate y2, subtract the y coordinates, y2 minus y1 plus y2 minus y1 into ay vector. The next, subtract the z coordinates, z2 minus z1 into az vector. Yes. Then okay, this is the distance vector. Then I want to realize this distance vector in terms of position vector. So I have point P here, I have point Q here. From origin, what I will do, I will join from origin to point P. This I will call it as RP vector, because one of the point is origin, RP vector. Then from origin I will join to point Q. This is the direction, okay, it is joining to Q. Then this is RQ vector. I will not write ROQ, RQ vector is a position vector. I want to express the vector RPQ in terms of the position vectors RP, small rp vector and RQ vector. So you can see the triangle law here, right? Tail to tip. So I want to establish the relation. Just observe here. What is RP vector? You write down RP vector first. RP vector. The coordinates of point P are x1, y1, z1. The origin is 0. So x1 into ax plus y1 into ay plus z1 into az. So this is the RP vector, because other point, the origin is having the coordinates 0, 0, 0. If apply distance formula also, no, we are subtracting is 0, so we will get the same coordinates x1, y1, z1 along with the unit vector. Similarly, write RQ vector. So the coordinates of point Q are x2, y2, z2. So x2 into ax plus y2 into ay plus z2 into az. Okay. Then next, I want to express this distance vector in terms of position vector. So RPQ vector is equal to, okay, somewhat okay. RPQ vector is equal to, always you subtract like this, RQ vector, the position vector RQ minus the position vector RP. So just subtract, RQ vector is here, RP vector is here, just subtract x2 minus x1 into ax, I will get, subtract RQ minus RP. So finally we will get, so here I have written, I will not write once again. So RPQ vector, what we, after subtraction of these two position vectors, we will get x2 minus x1 into ax plus y2 minus y1 into ay plus z2 minus z1 into az. So we can express this RPQ distance vector in terms of position vectors, right? Yes. If I ask you, okay, fine, no problem. I hope you understood. Yes, I will continue with the next topic. If any doubts are there in the middle, you can stop me at that moment so that I will tell once again. Okay, next we'll take up one problem. Given point P is given, P of 1, 2, 3, and it is asked, then find position vector and its magnitude. Yes, point P is given and it is asked to find out the position vector, right? And the magnitude of the position vector. So before solving any problem, it is better to draw the diagram, right? It is not mandatory, but it is better. In always field theory, it is better to draw the correct diagram, not the wrong diagram. If I draw the correct picture or figure or diagram, then 50% of the problem is solved. Remaining will be applying the formulas, whatever we know, right? So first we will try to, position vector means one of the point is origin, position vector, right? So yes, slate is moving somewhat, okay, I am not comfortable with it, okay, fine. Origin, so I will first indicate origin, because position vector means one of the point is origin. Then they have given another point P, 1, 2, 3. I will join from origin to point P. I am drawing the diagram, and this is the position vector, RP vector. Is it fine? So they have asked to find out position vector. They have asked to find out position vector. RP vector is equal to, so coordinates are 1, 2, 3. So 1 into AX. I will not write 1. 1 into AX is just AX, and 2 into AY plus 3 into AZ. This is the position vector we have found out. Then they have asked to find out the magnitude. Magnitude we represent like this: magnitude of RP vector. Write down RP vector and put two parallel lines. So this will be the magnitude of RP vector is equal to under root of the components here. Here component is 1 and component of y is 2, component of z is 3. So under root of component square. So under root of 1 square plus 2 square plus 3 square. So the magnitude turns out to be, I have written the answer here for my reference. If you want, you can calculate using your calculator. 3.7416 you will get. So we have found out the position vector and its magnitude. So this is not a big deal, but draw the diagram for any problem given. It is better to draw the diagram. Is it fine? Okay, fine. Already we have defined what is unit vector. The vector which is used to indicate the direction whose magnitude is unity. But mathematically we can define the unit vector as the vector divided by its magnitude mathematically. So example, I have given the example: unit vector directed along PQ. So I have point P, just let me locate it, and I have another point Q. I will join these points P to Q. Then what is the unit vector from directed along PQ? So I will indicate the unit vector here: A from P to Q. APQ, small letter A, APQ. APQ is the unit vector directed along PQ vector. So APQ vector. And by mathematical definition we know that the vector divided by its magnitude. The vector is P to Q, right? So the vector I will write here. The vector is distance vector. So RPQ. This is the distance vector. So I am using capital letter R because it is not a position vector. It is a distance vector. So the vector divided by its the vector is RPQ vector. RPQ vector divided by its magnitude. Magnitude of RPQ. So this is the mathematical definition of unit vector, right? So unit vector directed along any of the particular distance vector is the vector in the distance vector divided by its magnitude, right? Okay. Next another problem I given. Obtain the unit vector in the direction from origin towards the point P of 3, minus 3, 2. Yes, they have asked to find out the unit vector in the direction from origin towards the point P. So better to draw the diagram first. So origin is here, 0, 0, 0. Then point P they are given 3, minus 3, minus 2. I will join there O to P. Yes, find the unit vector in the direction from origin towards point P. Means I want to unit vector along OP. So the unit vector means, so I will be making use of the notation A. I will not write OP because O is origin by default for position vector. Just simply I will write AP vector. AP vector. And this is the position vector. So I will write small r RP vector. Right. So by the definition of unit vector, we know that AP vector, the vector directed along OP is the vector RP divided by its magnitude. So the vector RP is the coordinates of point P are 3, minus 3 and minus 2. Just associate the unit vectors for it. 3 AX minus 3, y is minus 3, so minus 3 into AY, Z is minus 2 into AZ divided by its magnitude of RP vector under root of this first one, 3 square, under root of 3 square plus minus 3 is there next, minus 3 whole square plus minus 2 is there next, minus 2 whole square. Now you can leave like this, or else I have given the answer here. If you solve after simplification, you will get 0.639 AX minus 0.639. Okay, you will get this answer. Is it fine? This is the unit vector in the direction from origin towards the point P. Is it fine? Yes? Okay. Magnitude is not okay. If I calculate this magnitude below on denominator, I will get 4.69. I have written that also, no need. If you want, you can calculate, right? Okay, fine. I hope you understood this. Okay, next. The 2 points A and B, A of 2 to 1 and B of 3 minus 4 2 are given in the Cartesian system. Obtain the vector from A to B and a unit vector directed from A to B. So let me look at the points A and B here. This is a distance vector. Is it fine? Okay. A of 2 comma 2 comma 1 and another point B 3 comma minus 4 comma 2. So I will join these 2 points AB. So this is the distance vector. So RAB, RA to B, this is the distance vector, and unit vector directed along vector AB is okay AAB. AAB, is it fine? So what he has asked, they have asked obtain the vector from A to B. A vector from A to B means RAB vector, the distance vector, RAB vector. Yes. So just apply the distance formula A to B. 3 minus 2, just subtract the x coordinates. 3 minus 2, 3 minus 2 into AX along x direction. Along y direction minus 4 is there. Minus 4 minus 2 plus of minus 4 minus 2 into AY. Then subtract the z coordinates. 2 minus 1 plus of 2 minus 1 into AZ vector. So finally you will get this vector 3 minus, here I have written the answer for this, just I will not write once again. This is the answer you will get. 3 minus 2 1 AX minus 4 minus 2 minus 6 AY 2 minus 1, right? This is the answer you are getting. This is RAB vector. Then you have to find out unit vector directed from A to B, means AAB you have to find out. AAB means the vector divided by its magnitude. RAB, the vector RAB divided by its magnitude of RAB. Yes, if I write the formula, that is sufficient. I will not solve because I have given RAB is here already. This is RAB we have found out. Then find out the magnitude. How to find out the magnitude? You know how to find out the magnitude? Under root of the component square. Under root of 1 square plus minus 6 whole square plus 1 square. So this will give me denominator. Numerator already I have this RAB. So this is the answer final. AAB is, this is the answer I have given here. Right? You can leave it or you can simplify it. So these are simple things. So I am going fast. Next. If any doubts are there, you can ask. Then next, yes, this is the most important thing you have to understand in electromagnetic theory, differential elements. If you won't understand, there will be a problem in future because you have for the basics. These are very much essential. Differential. What are differential elements? I will tell you. Right? So try to understand it properly. Okay, fine. I have a diagram in the next slide. From textbook I have taken, but I don't want to share it now because in the next slide it is there. First we'll try to understand by our own, right? So what are differential elements? Differential elements means, see here, if I move through a very small distance, I will call it as very small distance, right? Delta, by I want to move in x direction by some delta distance, I will call it as delta x because I am moving in x direction. If I move by a very small distance in y direction, I will call it as delta y, or else I will call it as dx or dy or dz, right? These are differential elements. So I will tell you, I will give before taking, I will explain you clearly. So once again, rectangular coordinate system. With respect to rectangular coordinate system, we are speaking x, y, z. Okay, this is the origin. Then I will locate on point P here. The coordinates of point P are, let me take it as x, y and z. Then I will take one more point. See, this point P is at certain distance from origin. This is the distance, right? So I will take one more point which is far away from the origin. which is far away from the origin. I will take one more point. Let me call this as P dash. So since point P and P dash is away from the origin, right? So P is having coordinates x, y, z. So P dash is slightly away as compared to P. So by a small distance, let me call it as x plus dx. Along x direction, it has moved by a small distance, x plus dx, y plus dy, z plus dz. I hope you got this. Here point P is having coordinates x, y, z. I will consider one more point which is far away from origin, maybe here or somewhere here, by a small distance. So what is that? So what are the coordinates? Then it will be, so for P dash the coordinates are x plus dx, y plus dy, z plus dz. Is it fine? Okay, then I want to find out the distance between these 2 points, P to P dash. This I will call it as differential length, because this P dash, if it is moves by a small distance along x direction, that is dx, along y direction dy, along z direction dz, by a small distance in x direction, y direction, z direction, I will get P dash. And the distance between the points P and P dash I will call it as differential length, dl. And the vector I will take it to represent dl vector. Is it fine? Okay, I want to represent in the 3D diagram and show you. So it will be very tedious to draw the 3D diagram. First, to draw the diagram very easily, what I will do, first I will make a cubical structure, then I will take the help of rectangular coordinate system. First I will draw the cubical structure so that it will be easy for me, right? Sorry. Yes. Okay, I will draw the backside faces with dotted lines so that we can identify easily. In the next slide the diagram is there, but before we have to draw, because in field theory we should be in a position to draw almost all the diagrams, so that 50% of the problem or numericals will be solved, our concept will be clear if I draw the proper diagram, right? So then I will take the help of the coordinate system. So I will draw this is reverse way I am doing. Actually first I should have drawn the coordinate system, then I could have drawn, but it will be very tedious, so better to draw the cubical structure first. X, y, z. So origin is here, right? So the point P is here, what I have shown here in the first diagram. Point P having coordinates x, y, z and P dash. So observe here, point P is here, the coordinates of point P, then P dash is here, P dash. Observe here, it is P is on the back face of the cubical structure, P dash on the front face, right? The coordinates of P are similar to this. Just I'll write the coordinates once again: x, y, z, x, y, z. And coordinates of P dash are x plus dx, y plus dy, z plus dz. Is it fine? These are the 2 coordinates. Point P, just observe the cubical surface. How many faces does a cube has? 6 faces, right? So we will call them faces here. This one, front face, just observe the pointer movement, front face, and back face, front and back along x direction. Here along x direction this is the front face, along x direction this is the back face. Then along y direction, this, just observe, this is the left face along y direction, and this is the right face, right face along y direction. Then along z direction this is the top face, just observe, this is the plane, this top face, and this is the bottom. Totally 6 faces are there. Along x direction 2 faces, front and back. Along y direction 2 faces, left and right. Along z direction the 2 faces, top and bottom, right? Totally 6 faces are there. And we know the coordinates of point P and P dash now, right? So this point P is in the back face and P dash is in the front face. So what will be the coordinates? See here, P is here, P dash is in the front face. So this distance will be, apply the distance formula, x plus dx minus x, means this distance is dx along x direction. Between front face and back face, that small distance is dx. Similarly along y direction, P is y, and p dash is y plus dy, y plus dy minus y, so I will be getting dy here, this distance from here to here along y direction, right? Then from in the top and bottom surfaces, here at the top z coordinate is z plus dz, in the bottom it is simply z plus dz minus z, so I will be getting dz. These are the differential elements. The differential elements are dx, dy, dz. These are the differential elements, right? Dx, dy and dz are the differential elements, right? Next, differential length I have told you. Differential length means join point P to P dash. Earlier in the first diagram I have shown you. So this, if I join point P to P dash, and if I want to find out the vector, this differential length, small differential means small amount of length, because point P and P dash are separated by a very small distance, not huge distance, what I have shown in the diagram, very small distance. Hence we call it as differential length, differential elements, all those things, right? So differential length dl. So how to write differential length, I will tell you. Differential length I will be writing here. Differential length dl vector is equal to, observe here, P is having coordinates x, y, z, P dash is having x plus dx, y plus dy, z plus dz. Just apply the distance formula and subtract it. X plus dx minus x, so I will be getting dx along x direction, dx into ax plus dy into ay. Sorry, it is ay, not az. Dy into ay. You don't make such mistakes. Dz into az. So this is the distance vector. And if I ask to find out magnitude, what is the distance between point P and P dash? You take just magnitude of dl vector is equal to under root of component square, under root of dx square plus dy square plus dz square. Yes, differential length is over. Next we will see differential volume, then we will go for differential surface area. First we will see the differential volume. So differential volume is represented by dV. So I will write here differential volume dV. We know that volume is, we obtain the volume by multiplying, since it's the cube, I will multiply length into breadth into height. You can observe here, length into breadth into height means the differential elements dx, dy, dz, right? Dz represents height, and length dx, dy, breadth, length into breadth into height, dx, dy, dz. So different, multiply all the three sides of the cube. So dx, dy, dz, dx, dy, dz. This is the differential volume. Because why we call it as differential volume? Because P to P dash, if I join cubical structure, it will be a very small volume between point P and P dash. Hence we call it as differential volume. Differential volume is over. Next, differential surface area. Yes. Okay, you can observe here the cubical structure has 6 faces, but I will consider the front face. Along x direction there are 2 faces, front face and back face. Front face means along positive x direction, back face means along negative x direction, right? It depends whether it is along negative x-axis, but it is in the x direction. Similarly, along y direction I have 2 faces, left face and right face. And this is left face and right face. Similarly, in z direction, top face and bottom face, right? Okay, fine. We will see the differential surface area. Differential surface area, general formula I will write in terms of vector. The differential surface area ds into the unit normal vector. I will tell you. It is this, I will tell you. This is the general formula for differential surface area. Means let me consider the differential surface area along x direction. X direction means in the positive x direction. I will consider the front face, only front face. Observe here, observe the pointer movement. This is the front face along x direction. So I want differential surface area along x direction. So ds x I will write. ds x means ds x vector means differential surface area along front face. ds x, this x indicates the front face, right? So what are the 2 sides of the front face? One is dy and another is dz. So multiply dy, these 2 sides. Multiply 2 sides, you will get surface area. So dy into dz. So dy into dz, and yes, there should be a direction. Along which direction? So along positive x direction. So the unit vector, this an vector is unit normal vector, which is normal to the surface. Because whatever I am writing to this PPT or board, it is always perpendicular, right? This this is the unit normal vector to the plane of the board, my pen or stylus, whatever I am using, right? So here in this case, along positive x direction, so the ax vector, because here the unit vector is ax vector along x direction, you know it. So unit normal vector which is normal to this front surface is ax. So write down, don't write an, it is general, now it is ax. So the differential surface area along x direction is dy into dz, multiply the two sides of the front face, dy into dz into ax. Similarly, I want to find out differential surface area along y direction, along positive y direction. Along positive y direction means this right face, observe here, this right face. So what are the sides? So this one dx, so I will write it as dx, and this is dz. So multiply two sides, dx into dz. So dx into dz, and unit vector normal to this is ay vector, which is normal to the front right face. So into ay vector. Yes. Next, I want differential surface area along z direction, means top surface. Top surface. I will come to the top surface. Observe here, this is the top surface. On this side, this is dx. Bottom here written, just I will take extend. This is dx. This side it is dy. So these are the two sides. So dx into dy. So multiply two sides, dx into dy into az. Az. Is it fine? Okay. We came to know the differential surface area along x direction, y direction, z direction. Without looking at the diagram also, I can write the differential surface area along x direction, y direction, z direction. Observe here, I will tell you, these are the differential elements, dx, dy, dz. I want differential surface area along x direction. So leave this dx along x direction, multiply other two, dy, dz, yes, it is dy, dz into the unit normal vector along x direction, that is ax. I hope similarly for others. I hope you understood this, right? Is it fine? Yes. Okay. This diagram, what actually I have drawn here in the previous slide, you can observe here. This is from textbook I have taken. Totally 6 faces are there. One side divides, the same thing I have drawn. The surfaces, differential surface area along x direction is dy dz into ax. Differential surface area along z direction is dx into dy into az. Differential surface area along y direction is dx into dz into ay. Is it fine? This is as shown. Okay. After this problem, we will wind up the class, or else 9:49, 9:50, 10, right? Okay. We will take the break, or else we will wind up here only. Okay. I will wind up here. Any doubts you can ask. I will give 1 minute. I will end the slideshow. I will save this PPT first.